And also another caveat from this is that if the derivative is 0, okay, it doesn't mean that there is an extrema at that point. Okay, let me write it down. So if f prime at c equals 0, it doesn't mean that that c is an extrema. Okay, remember that what this theorem says is that if there is an extremum at c and f is differentiable at c, then f prime is going to be 0. But the other way around doesn't work, right? If the derivative is 0, it doesn't always mean that this is an extremum. And the classical example is x cubed, right? X cubed works like this, more or less, right? The derivative of x cubed is 3x squared, and the derivative at 0 is 0. So it's clear if I, well, yeah, I didn't paint it correctly, right? Because if the derivative at 0 is 0, it means that it's flat right here, right? So it's something like this. Okay, at this point this is 0, but this is not an extremum, obviously, because it's not either a local minimum or a maximum. It's a point in which it is that the curvature of the function is 0. Sorry, it changes, but it's not an extremum of the function. Okay, so remember that. If there's an extrema at some point where f is differentiable, then the derivative is 0. But we also need to check where the function is not differentiable, and we also need to check that whenever we find a value of the derivative that's 0, then make it 0. Check that it is an extrema, because it can be the case that it is not. Okay.